presentation. Are we rolling? So the next chapter again should be review for us, but I need to go through some of the things. We quickly looked at the hardware configuration, then we got to look at the software configuration. Again, this should all be an ESP. ESP report, being able to get the configuration information, but there are things missing. So for example, Availmon and ESP can get my systune information. That's the main piece we're going to talk in this chapter. But also check config daemons. So in my inventory process, I want to find out what check config services are turned on. I want to list the versions so that if I'm upgrading libraries or products, I can actually do a diff between my two configurations. That's what ESP is doing. Every time I make a configuration change or use versions, it keeps track of those changes. So if I know I'm stable at the beginning of the week, by the end of the week I've got new libraries or something loaded, I'd be able to spot that with ESP, the embedded support partner. Other things that I grab are cron tab entries so that I can look at file system scrubbing, file system backups, things like that. The swap command, which we looked at briefly today already to figure out how's my swap configured. I also want to, in my inventory, grab DFs. At Warren's case, we did the DF to see how the file systems are made. And I also use LS to look at a few things like where is temp and var temp. Some sites will link user temp and var temp into temp. So I need to look for some of those sorts of link types of things that can happen. Because, for example, compilers and Showcase and Netscape will use var temp or user temp. And then applications may be in /temp. And there are different types of I/O. So Netscape and compilers has typically lots of little I/O. And you may want that at a different file system than /temp. So that's why I do an LS. And I also want to grab fstab to see what's in there. The trouble is that fstab does not cover fail-safe and it doesn't cover CXFS. So those are being mounted by other daemons that are not part of fstab. Now the people that train on those products advise people to put things into fstab just to document them, but that doesn't mean that it occurs. So there are a couple other files that you grab within the bsystest script to look for HAConf and CXFS-conf type files. Say, what are these drives being mounted as in terms of a logical file system? Now, unfortunately, there is a command that I really like that is not supported in IRIX, and the developer left SGI about a year ago, and it's no longer being supported for all the new types of disk drives. But it's called bstore. And my font is a little bit large here, so avoid the wrap. Now when I do a study, I usually have to do this by hand. So I get my print VTOC and get my disk configuration information. But the nice thing about this particular command is the way it lays out the picture. This is something that I was interested in Warren's machine, but we didn't have bstore on that particular machine. So here are my SCSIs. This is due again. I've got SCSI 0, 1, 6, and 7. The only thing on 7 is tape, so I don't really care about that. And then I can see for my other 3 SCSIs what type of drives they are, but the newer drives are not being supported. Some of the newer fiber channels and things like that, they're not in this command. That's why I'm just showing for demonstration purposes. So what I used to do is just take a piece of paper and then draw out my file system manually. So here I'm looking at, for example, on SCSI 0, I've got root A, root B, which I'm not using. Here's my home directory, and here's var/adm crash, and then I've got empty and CD-ROM. And one thing bad now is that I've got swaps. In particular, I've got a swap slice of user people. So if I start swapping, that particular drive is going to get more busy from the swap traffic. That would be a bad thing to do. And I don't like this file system layout. It's a good example of what not to do. Now my actual root is over here, the one that I'm running on right now, S1D2. That's the active root, and it has a dev swap. And then here's another bad thing that I don't like. Root C and root D are mounted. They're quiet file systems. Nobody's using them. But the swap slices on them have been mounted as temp. So I got 1, 2, 3, 4 temp slices sitting there that are on these spare routes. And this is probably a route that I don't know about yet. So that would be bad again. Now in this case, these other routes aren't really being used, so it's a way of taking advantage of them, but they might have been better off as swap. The other file system is this ptemp file system that was not mounting correctly. I might be better off using those two as my temp and putting these as my ptemp. Again, one of my key rules yesterday was minimum partitions to a drive. Look at some of these drives. I got 1, 2, 3, 4 slices there. I got 4 slices here. I don't advise that either. And these drives are a couple $100, if you can still get them, the older drives. So in my inventory process, I usually have to manually do something like that and draw some sort of picture and take the DF and the FS tab information and the hardware print BTOC information and lay out my file system. Now I need to do this before I start looking at SAR-D on my disk activity. So if I see a physical disk drive name, I know what file system that is and how it's put together. The other thing I'm grabbing then is my make statistics. When I make a file system, I got block allocation sizes and things like that. And it's GrowFS that actually shows me that information. I'm going to do that here. XFS underscore GrowFS dash N, and then it's going to ask me for the file system mount point. XFS underscore GrowFS dash N slash temp, for example. So during my inventory process, I now see that the inodes in the system are 256 bytes in size. We'll talk about allocation groups tomorrow. I've got 17 allocation groups, so I can have 17 files growing or shrinking at the same time. Every allocation group has its own structures, so that allows a file in each allocation group to change at the same time. And my allocation size for files is 496 bytes at a time, so every time I allocate a chunk of data on disk, it's going to be 4K byte at a time. We'll talk a little bit about this stuff when we come up to file systems tomorrow afternoon. The other mentioning here is checking for npadmin to see if I have any restricted CPUs. SN for page migration. And we're going to talk about miser CPU set to figure out if I have any restricted CPUs for miser. And lastly, if I've got any partitioning type of stuff. Okay. And again, I'm just going to do this now. I had a command within my toolkit called bsystest. So bsystest is designed, I can send it to a customer and then I don't have to keep going back to them and asking, what do you do here? What's your stripe geometry? What's your stripe unit size? All that sort of information can be handled in here. And note it's giving me serial numbers. I also check time zones, release name. So let me run that now. You got to be root to run it, bsystest. I'm just going to put it into a file called b.out.17 for the day. I should have done this yesterday. So right now it's doing the hardware inventory. Now it's grabbing the topology information. Now it's grabbing systune. It also grabs the stune file. It grabs striping statistics, buff view, checked on accounting, checked on K-Sync, whether that was turned on, checked on performance copilot, NQE, and a few other pieces. So out of that file now, out 17. I now have a inventory process that I can post on a web page. And the intent here now is if I rebuild the system, I can always go back to what my prior configuration was. I've got enough information to recreate the way that system is configured. And I can do diffs between this version and the next version. So there's my HINV topology. NetStat is in there to show me all my network interfaces. Route D options, there's my systune information. Now you were asking about a file. One of the files that I grab in my inventory process is the stune file. The systune command maintains all of its changes in the stune file. So again, when they release a kernel, stune is set to what are safe defaults. And when I look at systune, I can't tell what they've changed. So by grabbing the stune file, I can see, oh, one of the things they've done here is set nbuf to 300. That might not be very good. Okay. So this is a hot spot. Things that are in stune are things they've changed. Maybe that's part of my problem. I've also got 3 parameters here to turn on my accounting. We're going to come back to those in the next chapter. So my bsystest script ran all of this stuff. Okay. So I'm assuming everyone here has rebuilt the kernel at some point. Before rebuilding the kernel, always copy your current kernel off somewhere. So you've got a backup, and then at the boot prompt you have the ability to specify a different path name than the default. So if you can't boot on the new kernel, you can always, with the prompt command, say boot off the unix.bak instead of /unix. And again, inst is the tool to load software. In this case, I used it last week to build the system. Systune is what we're going to use and start changing parameters. And then yesterday I did do an auto config after I did the casing name dechange for PS to show block names. And then this was the problem yesterday I talked about. The kernel's copied to /unix on the next boot, but it didn't pick up the changes. So first thing yesterday morning I was still on the older kernel. And then in the afternoon we took a reboot and it came up on the new kernel. Whenever you come back up, you always want to double check to see if your changes took effect. One of the reasons it may skip this copying is if the actual file name in there is called unix.install. It's going to copy unix.install into /unix only if unix.install has execute permission, which is up to the compiler and the loader to successfully build the binary to give you. Okay, so sometimes you come up and the change did not occur because there was not execute permission on that unix.install file. So that was one thing I was doing yesterday, was double checking to see, am I on my current kernel? Can I cleanly build the kernel? Before I start changing things, I better make sure that I can cleanly build what I have. And I have had cases where the clean build wasn't there and I had to use inst to reload libraries or something like that. So we're into the process of kernel modification. And again, to me, the word here is, again, sizing. I want to size my workload characteristics and figure out how much they need, and then make sure my kernel has been configured for that type of workload. The more I know about my workload, the more responsible my configuration decisions are. So everything goes back to knowing the workload. And PAR is going to be a key one for us to talk about tomorrow. So you may be modifying kernel parameters, you may be putting in device drivers like the audit software. Some modifications require rebuilding the kernel and some don't. And I'm just going to go back to the system here and go in systune-i. And then I can do nbuf and take a look at how many buffers there are on the system. If I look at a group like resource, the top of the group will give me a group name. And if it says static here, that means a reboot will be required. If it says dynamic, like there is a paging group, the dynamic ones will change on the fly. For example, from cron events will take effect immediately and no reboot would be required. Okay?
I love hog swap, hog frac.
Yeah.
It's got to be the best one in there.
So I can look at an individual parameter, or I can look at a group, and when I'm looking at groups, it says static, meaning that a reboot would be required. The dynamic saying no reboot required. Now in the accounting area, EXT, ACCT, these were the ones that I had set manually to do my additional accounting. And that is a static group, meaning that a reboot would be required. So at this point, I hope that I've made all my changes to the kernel that are statically defined, so that I don't have to interrupt service and take reboots anymore. So it's just saying here some parameters can be changed without a rebuild. Those are the dynamic ones. The static ones do require an auto config and a rebuild to take effect. And then all the systune changes are kept in var sysgen stune. That's why I keep that file. So in my inventory process, I grab the stune file so I can see what have they changed. Because if I look at stune, I can't tell whether that was changed or not. So I had nbuff, and in this case it was at 300. I'm going to go to 400 just to go through the process here. And it says, do I want to change nbuff to 400? I say yes. And now it says a reboot is required in order for that parameter to become effective because that particular parameter was a static parameter. So now I'm going to quit, and then I have to do my auto config. And I always use a VF at this point. I'll catch it later, but I'd rather do it right now. And then make sure that I can cleanly build. So then I would have to reboot to get those changes to take effect. So in the workbook, that's all they're doing here. We went through in this example nonproc. I chose nbuff in this example. So here they changed nproc from set it to 100, and they wanted to change it to 200. The only thing missing here was the fact that a reboot would be required if I changed nproc. Now, documentation for the parameters was Appendix A of the system configuration guide that we looked at yesterday in the Insight manuals. If it's not documented there, the var sysgen mtune directory, wait for my build to finish. I know it's linking it. So in this var sysgen mtune directory, I got a whole bunch of files for my different areas of systune parameters. And for example, we were looking at the kernel parameters. So if I look at kernel, in here then are all the systune parameters. Don't always trust the comments here. Developers change code, and we have had the comments try to be corrected as code change, but don't always believe it. Kernel developers may make a change and it doesn't get reflected here yet. So some of us trainers have reported bugs on documentation like this. But this is where you find your best documentation for new parameters that were added. And the one parameter that I was looking at was nbuff. So here's nbuff, which is the number of buffers in buffer cache. On a 32-bit system, it can go up to 6,000 buffers. On a 64-bit system, 64-bit kernel, it can go up to 600,000. How can I tell if I'm a 32 or 64-bit kernel? Uname. If it says IRIX, that's a 32-bit kernel. If it says IRIX 64, that's a 64-bit kernel. So on do, we're a 64-bit kernel. On your workstation, you're a 32-bit kernel. So I'm going to bring up a calculator. If I have 600,000 of these buffers, that's the maximum that I can go to. How can I estimate the memory space consumed by these buffers?
64K?
Correct. Okay, I'll be there in a second. We're figuring out 600,000 times 64 kbyte because that's the default size of these buffers. Not a guarantee, this is just a rule of thumb, a rough estimate. That gives me a 38 gig kernel, the largest that I can grow on a 64-bit system. Let me get that out of the way. We were talking about where to find this data. It was in var sysgen mtune. And in there is a kernel file. And you have root on your workstations as well, so it's tip-top for your root password. Here's my JLimits group, which is fairly new. What I'm saying is this is the second place where you can go to find documentation. And here's where my defaults were. I was just looking for minimum. And here, for example, even here it's coming up as 1 instead of 0 where we had before. And again, the default was unlimited. So for some reason, the kernel wasn't exporting that properly. Going back to the workbook though, we're just saying that all this documentation for these systune parameters, first place was the Insight Manual, Appendix A. Second place is this mtune directory. The third place is the source code itself. So there may be new things added that aren't documented yet that you have to go to source for. So in that mtune directory we have the name of the parameter and then we've got the default. The default says if it's 0 or doesn't exist, when I boot the system I'm going to use an algorithm that is based usually upon memory. So the more memory I have, the bigger they set these numbers. And let me go back to this mtune kernel file again. Because in there was one of the algorithms. So if it's set to 0, depending upon a 32 or 64-bit, it's going to pick either the minimum of 100 plus the k byte of memory I have, divided by 160, or 600,000, whichever is less. Okay. So there's my default algorithm right there. So if I've got it set to 0, it's going to use that rule of thumb. And there's a routine in the kernel when I boot that says tune sanity, looks at the memory size, and then sets these things based upon memory size. nproc is another one that was in the workbook. Let me find that one. Okay, so the number of processes in the process table, here's the algorithm for that. So it's on autoconfig, it's going to start off with 40, and then for every 4 processes per megabyte for the first gig, 2 for the next gig, and then 1 for anywhere from 4 to 16 gig. Maximum it will set by default is 32,767. And that's the maximum we can go. Was there a question?
No, it's what is that? Sign in.
You can't really tell from here. You'd have to go into the code. Why they chose 32,767, I don't know. Probably a hole-friendly number for table size, so it's a power 2 type of table. Some of these others will also use nproc. For example, nc size is configured as 200 plus 2 times nproc. I'm going to come back to that later in the week, but that's the size of my directory name lookup cache and all my metadata. And that might be something useful on your machine as well to know. So the workbook's just showing the nproc group. In this case, the largest it can go is 10,000. So that's an older nproc. Now if you wanted to look at the system live, there's a dump command. You can dump the var group or you can dump the tune group. And this is just showing the syntax to look at it in the kernel. So basically for system parameter changes, again a site requires a different configuration unique to the workload. The more I understand the workload, the better I can configure it. So I'm trying to adjust the system configuration to match the workload characteristics. Also during my tuning process, I want to check sysmon. So again on my system, go into var ADM and look at syslog. Syslog, and for today, remember those kill problems. Here we have them visible in my syslog. So I was running out of swap. I was in a memory deadlock condition and the kernel did the kill due to insufficient memory and swap. I also had this error message show up. I tried to delete swap, but there were too few free pages to move what was in swap back into memory. That's when I got that earlier error message. So nothing of interest in syslog other than that message. And sysmon is simply the GUI. So a lot of your kernel changes start off with syslog error messages. So these are some of them. If I get no more process slots or forks failed, I may be increasing nproc or max up. Now job limits again make this confusing because the job limits will show up, for example, as forks failed, even though it's a job limit problem, not a nproc or max up problem. So I have had that problem before. None of the job limits stuff says it failed because of a job limit. A little bit about the process table, and the process table is converted to ASCII by the PS command. So when I use PS, for example, -L, all this data is coming out of my process table. And that's what PS does. There's also a SAR-V option to print the size of this process table. So if I do a SAR-V, look at my system, I can see that I got 6184, and the largest I ever got to was like 150, 190. I saw 190, but 162 looks like the largest. And I never had overflows. The second field here is the number of times that the table was overflowed on. And that never happened either.
What you say 161-6184, what each number?
The first one is the size of the process, how many processes are in the process table, the size of a PS command. And then the second one is what nproc has been set to. So if I go back to systune and grep for nproc, it'll show 6184. So if I'm running high on this one, if this one's at 6,000 processes typically on the system, then I may want to start upping that. In this case, I don't. I have one site, AOL, that they have a script that goes off and spies at everybody to see what they're doing. And that thing forks off 100 processes per user as it's trying to do all of this different work and it's spying. So every 10 minutes or so, they get this process storm that occurs as they fire off this script that's looking at what everybody's doing. And in that case, they did have to up nproc to be able to handle those every 10-minute events. There are other tables mentioned in the SAR command, but there's no way of changing the size of them. They're dynamically changed. So there's our inode table, file table, and also for locks, file locking, our lock table. And that's the end of this chapter.
Overflows, is that okay?
Yeah, as far as I can tell. This is a historic thing. Older Unixes, it was a static table, but now they're dynamically allocating it on heap. Only the process table is static. But there may eventually hit a hard limit that's kernel built.
I noticed what, the number of files, that's the number of files that are open?
Number of inodes in the inode table, not necessarily open, but I think that's the in memory.
Okay, you got inode and then you got file.
You can have a file open, but the inode was in memory to find the file, but then the inode might have got squeezed out, but I still have my open file table to find the inode.
The third column, or the third one is your file,
Right.
number of files. That one there?
Number of files in the open file table. So I've got 980 inodes that are open and 257 files. Remember, standard in, standard out, standard error basically have a file type. Not really an inode, I guess, they have an open file entry point. So this is dynamically changing. You can see that the maximum size here changes depending upon. Right in here, for some reason, it went from 4,000 to 60,000. Again, these are 1-minute samples, and there could have been an event during that 1-minute sample that upped it. You can't see it here. But I would not worry about anything other than the process table one. The other ones I consider historic types of information.